different. This is how we estimate or calculate the quantity of earthwork in excavation and partly in excavation and partly in banking. Now, let us discuss about the third case for the earthwork in canals. Case 3, that is earthwork fully in embankment. When the cross section of a canal is completely in embankment, we can visualize here the cross section which is completely in embankment. This is when do you say that the cross section of a canal is completely in embankment? That is, this is the ground level of the ground level and this is the bed level of the canal. When the bed level of the canal is completely above the ground level, then we say that the cross section of a canal is completely in embankment, or we can say it the cross section of a canal is completely in banking. This is the side slopes, outer slopes, and this is inner slopes. If B is the width of the section and D is the depth, and we can calculate the total width of the section. How to estimate the quantity of earthwork when the cross section of a canal is fully in embankment? Let us see now. The quantity of earthwork may be calculated considering the whole as a solid and then deducting the channel portion. That is, considering the total as a solid section and then deducting the channel portion, we will get it is the capital D is nothing but small d plus h, where D is a total depth and small d is the depth of the channel portion plus h is a height of banks. B, total width of the canal in embankment is nothing but small b plus B1 plus B2 plus 2N1 into D. So, the quantity of earthwork is nothing but the whole sectional area, that is we are considering the total sectional area minus the sectional area of a channel. Sectional area multiplied by the length will gives the quantity of earthwork. Substituting the values for the sectional area for channel as well as for a solid, that is BD, B into D plus N1 into D square minus B into H plus N1 into H square multiplied by the length will gives the quantity of earthwork when the cross section of a canal is in embankment. This is how we calculate or compute the quantity or volume of earthwork when the canal section is completely in excavation, when the canal is partly in cutting and partly in embankment, and also the third case, that is when the cross section of a canal is completely in embankment. Now, let us see the general cross section of a canal when it is completely in excavation. This is the ground level, this is the bed level of the canal. N:1 are the side slopes of the canal. If small b is the bed width of the canal and small d is the depth of the canal in cutting, this is N into D and this is N into D. Now, before knowing how to calculate the quantity of earthwork for a canal or a road, we should know how to calculate or compute the area of cross section of a canal. Now, let us see how to calculate the area of cross section of a canal. Calculation of area of cross section of a canal. Let B is equal to width of the canal at the bottom and D is equal to depth of embankment or cutting. That is, since the cross section of a road or a canal is same, that is in the form of a trapezium, we are considering the depth of embankment or in a cutting. N:1 are the side slopes, that is N horizontal is to 1 vertical. The top width of cutting or bottom width of embankment is nothing but the total width at the bottom of the canal section, B plus 2 into N into D. So, computing the average width is nothing but the summation of the bottom width small b plus the top width, that is b plus 2nd. The average of bottom width and top width will give you the average width of the canal section. So, the area of cross section of a canal is nothing but the average width multiplied by the depth. The average width is b plus n into d multiplied by the depth of the canal is d. So, the area of cross section of a canal or a road is b into d plus n into d square. This is how we compute the area of cross section of a canal or a road. Now, let us see how to calculate the area of cross section of a canal or a road taking a simple example problem. To find the area of embankment if the top width is 5 meters, that is the top width of a road is given as small b is given as 5 meters and the depth is 4 meters. The depth from the ground level to the top of the embankment is given as 4 meters, small d is 4 meters. So, the side slopes are 2:1. Here n:1 is given as 2:1. So, how to compute the area of this embankment, road in embankment? Let us see now. Just now we have discussed that the top width is given as given data 5 meters, the depth of the embankment from the ground level is 4 meters, side slopes n:1 are given as 2:1. So, the formula for calculating the area of cross section of a canal or a road is b plus n into d into d. Substituting the above data or the values from the given data, we get the required area of an embankment. This is how we compute the area calculation for a road in embankment. Now, let us see one more example for a canal section. To find the area of cutting if the bottom width of a canal is 3 meters and the depth is 2 meters. The side slopes are 1:1. The following visual shows the cross section of a canal in cutting, where the bottom width is given as 3 meters and the depth is given as some 2 meters. So, this is the ground level and the side slopes n:1 are given as 1:1, where n is equal to 1. Now, substituting the above data, we can compute the area of a canal in cutting. The given data is the bottom width of the canal is given, the depth of the canal is given, the side slopes are given. So, the area of cross section is nothing but b plus nd into d, where b is the width, n is the side slope, d is the depth of the canal in cutting. After substituting the above values from the given data, we can compute the required area for the cross section of a canal in cutting. This is how we compute the area of cross section for a road or a canal, either in cutting or in banking. Now, let us see what are the various methods for calculation of quantity of earthwork. The calculation of earthwork either in excavation or completely in banking may be calculated by the following methods. They are, the first method is mid-ordinate rule or mid-sectional method. The second method for calculating the quantity of earthwork is mean sectional method. The third method for the calculation of quantity of earthwork is trapezoidal rule. The fourth one for calculation of quantity of earthwork is prismoidal rule. These are the various methods for estimating the quantity of earthwork. Now, let us discuss about these methods, each one by one. Method 1, mid-ordinate rule or mid-sectional method. In this method, when the ground is in longitudinal slope or the formation has uniform gradient for a length L, then the average depth is found at the midsection. Mid-ordinate rule means the average depth has to be found at the midsection. We shall see in the following visual now. This is the longitudinal section of a road, that is, if D1 is the depth of a road or a canal at first section, say this is A, and D2 is the depth of the canal or depth of banks at the other end. So, if D1 and D2 are the depths and B is the width of the road, so we have to calculate the area, or first of all we have to calculate the average depth of cross section, that is mean depth at the midsection. Let us see how to calculate it. So, the quantity of earthwork is computed as follows. Let D1 and D2 be the depths of bank at two ends. So, the mid-ordinate or average depth dm, that is nothing but the average of these two depths D1 plus D2 by 2. The area of midsection AM is nothing but B into dm, where dm is the average depth plus n is a slight slope n into dm square, that is average depth square. So, the quantity of earthwork between the two sections by using mid-ordinate rule is calculated as volume or quantity of earthwork is equal to area at the midsection multiplied by the length between the sections, that is equal to B into dm plus n into dm square multiplied by L. This is how we compute the quantity or volume of earthwork between the two sections by using the mid-ordinate rule. So, after getting the above values or the results, they have to be tabulated in the tabular form by using the mid-ordinate rule. This is the first column is the chainage, next is the depths or heights in meters, this is the mean depth or height, this is the area of the central portion, area of sides, and this is the total sectional area, which is summation of area of the central portion plus area of the sides, and the length between the sections is designated as L in meters. So, the quantity is nothing but the total sectional area multiplied by L, which is either in embankment or in cutting. Now, let us solve a simple problems how to calculate or compute the volume of earthwork by using mid-sectional method. Let us take a simple problem. A canal is proposed to be excavated between 2 points A and B 100 meters apart. That is, the distance between the 2 points A and B is taken, L is given as 100 meters, and if the bed width is 10 meters, small b is given as, the bed width is given as 10 meters. Side slopes 1.5:1, that is n is to 1 is 1.5:1. N is nothing but here 1.5, and the depth of cutting 1 meter and 3 meters at A and B, that is D1. Suppose we have assumed that D1 and D2 are the depths. D1 is nothing but here 1 meter and D2 is 3 meters at A and B respectively. Now, it is required to calculate the quantity of earthwork in excavation by mid-sectional area method. That is, by using mid-sectional area method, we have to compute the quantity of earthwork. Let us see now. From the following visual, it is clearly shown, this is the end A and this is the end B. The length between these two ends A and B is given as 100 meters, and the depths at end A, first section, is given as 1 meter. Similarly, the depth at the other end is taken as 3 meters. So, we know D1 and we know D2. Let us see how to compute. This is dm, where dm is nothing but the average depth of the sections, which is nothing but the average of the depth at first section and depth at second section. Let us see how to compute it. This is the given data for the given problem. Now, how to compute it? The average depth we have to compute it, that is dm is nothing but the average of the two depths d1 and d2 by 2. So, we get some in meters, the average depth in meters.